So in this video, we're going to do 4 different methods. I already have a video out for the AC method, so this one's going to be pretty quick. But I'm also going to demonstrate long division and synthetic division used in order to factor these, as well as the quadratic formula, in lieu of having to utilize all these different factoring methods, or if you simply just get stuck when you're trying to group or use the AC method, or vice versa. Let's do the AC method first. For the AC method, we have 14 times 4. That's going to give me 56. And then if I factor 56, I could use 28 times 2. That's going to give me 14 times 2 times 2, which leaves us with this. And this is the lowest. These are your factors, your lowest factors. So now I look at this list and I can see that 28 plus 2 is going to give us 30x. So I'll put that right here. The 2x portion of this is going to go right here, right? I'm going to put 4x squared here. And we can see that 2 and 4 and x, that's going to be easy to take out. And then right over here, we're going to have 28x plus 14. And I'm just going to continue through with the work. Take a 2x out over here. You'll be left with a 2x plus 1. And right here, we can take out a 14, leaving us a 2x plus 1. And that's what I needed. I needed that 2x plus 1 so we could take it out. Since it's common, it's a common factor to both 2x and 14. Another thing is you can cover these up, and you can see that if you take anything out of this, right, we're just using the distributive property on 2x plus 1. I call it bubble math. Just see those as a bubble, that common factor, and you just pull out the bubble. You're left with this. We're going to pull out that bubble, or what's in parentheses, and that's going to leave us with this. Now, you want it in complete factored form. I'm going to state that we can see that one root is this. I wasn't asked for that, but it might become useful down the line when we use the quadratic formula on this, as well as long and synthetic division. So now we're on the long division portion. This is really the fundamental theorem of algebra. And what you do is you look at your last term, the coefficient for that, or the constant respectively, and the coefficient in front of a. Then when you have this, you're going to guess. You're going to guess factors of c and factors of a. Anything that is a factor of c or a, or the ratio of c over a, are going to be possible factors for this trinomial. So that means that the only possible factors are going to be listed in our list that we have here. You're not going to have anything outside of that list, but it doesn't mean that they're all factors. It just means it shortens your guesswork. So I'm going to put 14, is that right? Yeah, 14, and I'm going to put 4 here. I'm going to switch back to my Burple. So I've got 1, 2, and 7 for possible factors of 14, or for the factors of 14, sorry. And then we're going to have 1, 2, and 4. Now, that means that the possible roots or factors, if you guess one root, you'll get another. So really, you might think, okay, I've got 4 and then the fractional, about 6 different choices. Well, not really. You're cut in half to 3, because once you find one and use long division, you'll automatically get the other one. And so the possible roots for this are going to be 1, 2, 7. Here, let me do it in order. 1, 2, 4, 7, and 14. But you're also going to have the ratio here. 7 over 2. And then we also have, what's another one? 1 over 2. 2 over 4 is just 1 over 2, so we don't repeat that. 14 over 4 is what we started with. So the other possibilities are going to be 1/2. And all of this is plus or minus, by the way. I'll fix that in a second. And we're also going to have, what was the other one? 7 over 2. If I guess, let's say a 7. Let's say a -7, right? So that means you write x equals -7. If you want to do long division, you need to put it in factor form, right? Or binomial form, respectively. So we're going to put x plus 7, and we're going to start our long division. So if I guess a 4x here, and I put a subtraction sign here, then that allows me to quickly do this without making any sign errors. That's why I keep that out. So when you do this, you're going to get 4x squared. We'll end up subtracting that in a moment, and you follow through with the 7. That's going to give you 28x. Now, if you bring your negative sign in, that's why I do this, you won't make any mistakes. You're not forgetting it when you So we need to keep that out until after we multiply 4x times the x and then the 7. So it's going to give me 0 here, 4 minus 4x squared, and then 30 minus 28x. Remember, it's there. So that's going to give me a 2x. We don't include 0, of course. And we're going to drop our plus 14. And then we make another guess. So my guess, let's look. Let's do a 2. Because we need that to be a 2x. So multiplying times that and that again, you're going to get 2x down here. Notice how I'm putting them inside the brackets, plus 14, and then we distribute. Well, this minus this entire quantity, that's simply just going to give us 0, right? 0 plus 0 is just 0. So that's done. What does this mean? It means that what we have is this right here. And what I like to do usually, and I didn't do it at the beginning, is I'll set it up with my guessed factored form here. So I did that over here. We are dividing it by that guessed factor there. And then I'm going to go ahead and now when you're doing this, do not factor this and then cancel the x plus 7s. Okay, that would defeat the purpose. Do not do that. That x plus 7 wasn't there in the beginning. We're putting it in there now in order to get this over here. So just make sure you're aware of that, because if you do that and you factor this, you're going to get, it's just not going to check out right. So I'm going to put the answer that we got for the quotient, which was 4x plus 2. And then what I do from this point is that I need to put that x plus 7 back in, right? So we do that here by multiplying both sides times x plus 7. So I'm just going to show that real quick. These are going to cancel now. Now you can cancel them, right? When you multiply x plus 7 times 1 over x plus 7 there. Or 4x squared plus 30x plus 14 over x plus 7. Again, do not factor this and then cancel. That would not be right. So then we're going to have this. And what we can see from this, if we factor this just a little lower, because we could take a 2 out of that, we'll be left with 2x plus 1 like we had when we did the AC method, right? And I want to kind of revisit that there. We can see that that is, in fact, what we got in our lowest form. So we're going to go with the same logic. We're going to take our C over our A. That's going to be 14 over 4. And we're going to place that here. Then we're going to have negative 7 for one of the roots. And this is a really fast method. So I'm going to put negative 7 right here. All right, we're going to multiply that times the 4. We're going to get negative 28. We're going to sum up this. Every time you multiply, you get a product over here. We're going to sum it up. You sum up your columns. And then we're going to do the same thing right here. And we're going to get negative 14. That gives us a 0. If your remainder equals 0, then you found a root. Okay, so now that when we're done with doing our synthetic division, we need to write back what we had to begin with. So it's a nice way of showing and testing our work. So in order to fix the algebra up here, we're going to multiply both of these so we can get rid of what we just did here. This is just me saying, okay, I'm dividing this by x plus 7, our guess. We used long division on that prior, and I explained that. So there we go. Make sure you put that in parentheses too. You might want to do it before, but and then these two are going to cancel. And that's it. But we can actually take a 2 out as well. And we'll be left with our factored versions here. All right, the quadratic formula on this. And this is a relatively long process. You only usually want to do this if you it's like my last resort. And when I say long process, it's not that bad. I'm just saying. And you're going to get 2 possible roots. So it gives you your 2 immediately. That's the good thing. It does have its pros. So I'm going to let this just equal y. We're going to take out a 2. And these are going to be our two possible roots. 2a is going to give me 4. Okay, that's going to end up giving me something nice. I've got the square root of 169 here. But to get it in factored form, make sure that you're not reducing down until the end. Okay, I'm going to show you why that's important. So for this one, we're going to have, I'll put 4x. Go. And over here for the other one. Oh yeah, of course. Now, if it comes out as an integer, you are allowed to. Okay, so when I said do not factor this over here, true. But if you get an integer here that you can pull, you can go ahead and do that, right? If it's a nice integer, you're allowed to do that. So go ahead and do this, and then that factored form is this. You put them together, and it's factored. Almost. We still have to factor out that 2 like we've been doing. Well, if we factor our polynomial using the quadratic formula and getting our roots in factored form, right, then we're able to factor this thing. It's another way to do this. So you kind of pick your poison, what your favorite method is from this video. Mine's usually synthetic division, but you need to be able to do all of them because not all of them, some problems you're limited to which ones you can use. That's what the purpose of this video kind of was. In a way, I was just showing y'all what how you can do every single one from one problem as well. All right, well, hope that helps.
Coming! Let me coming!